This is the fourth part for activity 3, and in this part I'm going to compare the proportional relationship to the non-proportional relationship. I'm going to look at graphs for both of those and use the slope triangle for the non-proportional relationship and talk about what that means. So in the first case, the dotted line once again is the proportional relationship, goes through 0, 0, so you can simply divide the value for y, the y coordinate divided by the x coordinate, because that point right there, which is 1, 2, that 1 is the change in the horizontal direction. It's the horizontal change is that 1, because it goes through 0, 0, 1 minus 0 is that 1. And because it goes through 0, 0 again, 2, the coordinate for the y value, 2 minus 0 is 2. So this is the change in the vertical direction. Just turns out it's the same as the coordinates. So 2 divided by 1 is 2. 6 halves divided by 3 halves. So 6 halves divided by 3 halves. Well, if you have 6 of something and you divide it by 3 of something, 6 divided by 3 is right here. 6 divided by 3 does equal 2. And the last one, again, this 11/4, that's 2 3/4. That is the horizontal change. That 11/4 right there. And this 11/2, which is 5 1/2, so you go up 5 1/2, that is the vertical change. They are the same when the line goes through 0, 0, because in both cases you're subtracting 0 from each case. You're starting at 0, you're ending up with these points, and so that is the horizontal change and the vertical change. So 11/2 divided by 11/4. Bunch of ways to do this. Just going to take 11/2, use the use the inverse operation, which is multiplication, and now use the multiplicative inverse, which is 4/11. Notice that the 11ths cancel out, or 11 actually cancels out. You're left with 4 divided by 2, that's 2. So in every case, this is the constant of proportionality. It is constant, it's the same, it doesn't change. And also it's the repeating part. So for 1 unit in the horizontal direction, 2 units in vertical direction. 1 unit, 2 units. 1 unit, 2 units, right up to there. So it is the constant of proportionality. So now if we translate this line, if we move it up 3 halves, so this is 1 half, 2 halves, 3 halves. Each one of these points translates up 3 halves. So this is the 1 half right here, this is the 2 halves right here, and this is the 3 halves. And then we're going to recalculate the slope based on that change. And notice that that movement up tells you what the y-intercept is. It is 3 halves, because when x is 0, we're moving this up 3 halves, so it's going to cross the y-axis at 3 halves. The name of this point is 0, 3 halves. Now I'm going to use this table, and I'm going to use these last 2 points here. So we're going to start at 4.5, and we're going to go to 7. We're going to start on the x-axis. We're going to start at 1.5 and go to 11/4. And remember, 11/4 is 2 3/4. Talk about that, use that. All right. So we're going to use these last 2 points up here. So we're starting at 1.5 along the, it's right here, 1.5 along the x-axis, and we're ending up at 2 3/4. Well, that's the same as going from 1.5 or 3 halves, 1.5, to 11/4. And so if you change everything to fourths, this is 6/4. So we're going from 6/4 right here, this is 6/4, to 11/4. And we're going from 9 halves, so this is at 9 halves right here. 9 halves is the same as 4.5. So 9 halves to 28/4. So now they really kind of mess you up in that you have to think about different denominators, different fractions to solve this. And we're going to do this in a couple of different ways, but this is the detail that students have to think about as they go through these problems. So we're going from 4.5 or 9 halves to 7, which is the same as 28/4, or 14 halves. So from 9 halves to 14 halves. All right, so to calculate that change in y compared to the change in x, so for the y value, we're going from 18/4. So this is 9 halves right here is the same as 18/4. And we're going to 28/4. So I'm going to change everything to fourths. This was 9 halves. 9 halves is the same as 18/4. So we're going from 18/4, which is right here, and we're going up to 28/4, which is the same as 7. And along the x-axis, we're going from 11/4. So this is 11/4 right here, which is the same as 1 and 11, or we're ending at 11/4, sorry. So we're going from 6/4, which is right here, this 6/4, and we're ending at 11/4. So remember that 3 halves is the same as 6/4. So you're subtracting from where you're starting, you're subtracting that from where you're ending up. So this is 11/4 minus 3/4. Let me go through that one more time. So the change along the y-axis is this 28/4 minus this 18/4, which is the same as 9 halves. So 28/4 minus 18/4. That's this change subtracting this amount right here. To get this down, actually you're basically moving this down to the x-axis. And along the horizontal axis, you're starting at 6/4. So this is 6/4 right here, which is the same as 3 halves. And you're ending at 11/4. So you're going from here over to here. This down here, this is 6/4, which is 3 halves, 1 and 1/2. And you're ending at 11/4, which is 2 and 3/4. So this is 2, 1/4, 2/4, 3/4. A pretty good example of how much is going on in this problem. Now, you can do this a variety of different ways. You can have students solve this where they change everything to halves. You can have students solve this where they keep everything as a decimal value. And I'm going to do that in a moment. You could use a mixture of halves and fourths and figure out what you get. But in this case, if you change everything to fourths, then you can look at this as 28 minus 18 is 10. Turns out it's 10/4, but you just focus on the 10. And 11/4 minus 6/4 is 5. It's 5/4, but just focus on the 5. Well, if I have 10 of something divided by 5 of that same thing, what's 10 divided by 5? That is, in fact, 2. Now, mathematically, if you take the 10/4 and you use the inverse operation and multiply by the multiplicative inverse, which is 4/5, these 4's cancel out, and you end up again with 10 divided by 5 is 2. So if you change everything to halves, it's going to work out the same. Just use slightly different numbers, and you have to go through the arithmetic. You better end up with 2 as an answer. So this is a nice place where you can do the calculations. If you end up with 2, more than likely you've done it correctly. If you end up with something else, you have to go back and figure out where your mistake is. But the bottom line, this vertical change is 2 units, 1 unit, 2 units, and the horizontal change is just 1 unit from here to here. Now, I'm messing up. This is 2.5 units, actually. So this change is 2.5 units. This change right here is 1 and 1/4 units. So 5/4 is 1 and 1/4. So if you think about it, 2.5 divided by 1 and 1/4, that's the same as 2 and 5/10 divided by 1 and 25/100. So that ratio, that comparison is 2, gives you a slope of 2. And I kind of messed this up a little bit. It's hard to go through, hard to think about. Just keep on practicing. So let's look at doing this calculation with decimals for just a second. So this is 7 minus 4.5. So I'm going back to here. So 7 minus 4.5. So that's the change. Going from 4.5 to 7. You're going to take the 7, subtract that 4.5. And this is 1.5 to 2 3/4, by the way. So that 2 3/4 minus this 1.5 is going to be the change in the x, the horizontal direction, the horizontal change. All right, so 7 minus 4.5, and this is 11/4 minus 1.5. So to make this a little bit easier, first of all, 2.5. This is 7 minus 4.5 is 2.5. But 11/4 minus what? Well, this is 3/2, and that equivalent fraction is 6/4. You have some choices. I just chose to make it 6/4, so I could subtract that from 11/4. So now I have 2.5 divided by 5/4. Well, you might know that 5/4 is the same as 1 25/100. This is 4/4 plus 1 more fourth. That 1 is 4/4 plus 1 more fourth. And if you divide 2.5 by that, 2.5 is 2 times this amount. So 2.5 divided by 1 25/100 is 2. So different ways to do this problem. And again, I would have one student make the calculation one way with all fourths or a mixture. Another student do the calculation a different way, and even a third student do the calculation a third way, and talk about why they all get an answer of 2. Finally, if you compare the slope to the constant of proportionality, for a proportional relationship, they are the same. For this relationship right here, this dotted line, the slope is the same as the constant of proportionality, because in both cases, the change is subtracting 0. So the y-coordinate is the vertical change, the x-coordinate is the horizontal change, so the slope is going to be the same as the constant of proportionality. That is not true if the relationship is not proportional. Linear relationship, but it's not proportional. In that case, you have to look at the change in y compared to the change in x. That's going to give you the slope. The constant of proportionality does not exist in this case because it is not a proportional relationship. So you have to, the whole point of this is to make sure that you're working with the change in y and the change in x. So don't get fooled into saying, oh, gee, I can just take the y-coordinate and divide it by the x-coordinate. You cannot do that if this is not a proportional relationship. It has to go through 0, 0 to be able to do that. A lot of stuff going on.